Probes, as the name implies, is a great way for you to get a little bit of information out of your solution while the system is solving it, right? So the idea is that you define an expression that's evaluated and displayed onto a plot while your software is doing the time stepping. That way, if you have a larger system, you can kind of keep an eye on it and monitoring it, and you can cancel it if need be if you've done something wrong or if it's gone awry. They are basically a special case of the non-local coupling variables in that they can be used to collapse information over a domain, a boundary, a set of points through operators like integration, average, max, min to a scalar variable, which is then plotted over time. So that it's very nice and easy to see. So if we look at our effective diffusivity example, in this case, we defined a non-local coupling variable, which was the average along this boundary here. If we wanted to, instead, it's a little bit of an underuse of the power of non-local couplings. We'll get into it later. They're actually much more powerful than that. Alternately, what you can do is go to probes, boundary probes, right? Domain is the whole thing, boundary is an edge, point is a point. Domain point probe, I'll come back to in a second, right? You click the boundary one, clear out the selection, and just select the boundary we want. And probe type, we have average, max, min, integral, right? So what we're going to do here is we're going to take the average of the expression there, which is the amount of flux that's leaving it, and when we solve it, you're going to see a new figure popping up, which is our probe plot. So this is our average flux quantity that's being displayed as it's calculating, as the software is showing. Also, under results, under tables, you also have a probe table, which is recording all of your data points that you've been calculated. By default, this is updated and recorded according to the actual calculation steps from your software, not necessarily your output times, which reminds us about the time stepping cautions. Okay, so the other possible probe types, just coming back to the types, domain, boundary, point, those are all pretty self-explanatory. Global variable probe, also self-explanatory. Domain point probe is one of the few places that I'm aware of where you can sample the result from a solution or the particular value of a solution at a point which is not a geometric object. You don't have to insert a point somewhere and then select, okay, I want that value at that point. You can actually specify the X and Y coordinate. And maybe you want to slap to the closest boundary, maybe not.